I decided to choose this title, maybe based on the next slide, that we had a lot of discussions about data, about how pre-processing, how important it is, about algorithm. Sometimes we slightly miss the other elements. In a whole data analytics process, you have usually an issue. Then you have the work, data, the analysis, and in the end, you need to have the interpretation of the results and the action. We are in the executive track. That's the reason why I wanted to point out that on the point of the issue and on the point of the interpretation, people that are people we are talking to are not scientists, are not data scientists. So we think that it's really important to have ways of communicating results properly. And that's also, I come back and, to the name of IMSD. M is for multidisciplinary data science, not only doing algorithm and operations, but also to be multidisciplinary, to understand the issue of the customer and to understand, to help him taking actions. It might even be that the issue doesn't go over data analytics, it can go in another direction. And that's also a specificity of IMSD. We don't have a product you could download or try or compare with other. We do consulting. We go to customers, we discuss the issue, and we try to find the best way to get proper action. One important point, that's one part of the title as well, is truth. We had some nice introduction this morning by Professor Sturm about economics estimation, and it's quite clear, it was quite clear there that there is a lot of information, all these indicators are based on information that is not very precise. And the amount, the percentage of information that is available here to take a decision, to make a step, is really different from one process or from one issue to the other one. I was just thinking about one example for big data is always Google. Google is a perfect situation for this kind of data completed or to have all information available. Whoever expects when you make Google search to find an answer that is not on the internet? I mean, you have all the data available, so you can just work and do things. If you are at the opposite, you think about finance, prospecting, having some information about finance for the future, weather forecast. There is a lot of information that is not available for the people doing the analysis. And in the medium is more or less a specificity of IMSD. We try to work with people working with technical data, so having processes, and they have temperatures, they have pressures, they have some information, they don't have some other information. So I think this plot is important, and the next slide is important to consider. The algorithm you have in all these methods, they don't make the difference between the left part and the right part. They just take the data as it is and they try to model it, and maybe we have basically no chance to model it properly, or we have all data available. The algorithms, they work the same. One more thing, they don't really know what information could be interesting. So you can of course train them, you can give them some hints, you can tell them the sign of the correlation as we heard this morning. But then they work, they just take some data in, they process it, and they just produce a result. Be careful, don't trust this result too much. It could be completely wrong. And the next thing is, they're usually based on violated assumptions. It means that they think that the landscape of your data is more or less continuous, that your data has a normal distribution and things like that. Of course, things more or less work properly if it doesn't. But it can also go in any direction. So really be careful about just using a tool and believing that the result you get is reasonable try to understand what's happening. That's also one piece of advertisement. I represent also the Swiss Statistical Association. We have a booth out there. And we think that it's really important not only to have the best algorithm of the world, the fastest algorithm of the world, also to be careful to think about what is in this data. And that's what I want to present today. And one of the, we could say the best methods available today is so-called ADF. It's a kind of highlight of today because I think nobody heard about these methods before. It has been tested many times, and what does it mean, ADF? It's just that any damn fool can see what's happening if you're just plotting your data properly. So before doing anything, any analysis, try to find a way of plotting your data. I think I've got on the next slide, on this slide, an example. This was a project in a large company. We were in discussions with the people in the company and thinking about, does temperature influence the process? The temperature, the local environment or the temperature? And the answer was, don't worry about that. The local environment temperature is absolutely constant. This was, this should have been the black dots. And then we looked a little bit at the data. We could see some variation. And they told us, there are some sensors that are not properly working. Don't worry about that. Okay, look again at the data. You see that these black dots, they are more or less constant. But at certain times they go down, okay, maybe a failure of measurement. Surprisingly, they always go down up to the red light, the red line. What is the red line? It's the outside temperature, the external temperature. So it's not a measurement that is a failure. It's just that probably for some reason, and nobody remembers about it, they've been just opening the door of the factory for 1-2 hours or 1 or 2 days, and the cooling system couldn't deal with that. So if you plot your data properly, you see these things basically directly, but you would never have seen that if you had a listing of all this data over months or years. Why is it so important to plot data? Because we are convinced that a human visual system is basically the best analysis tool. It's just you should give him the food to be able to make this analysis. I mean, this pictures are quite well known. Find computers and find out the tiger in the middle of the picture. It's going to be quite difficult. But our human eyes has been trained for centuries to recognize, to try to find out some features. If you plot your data properly, and there is some information in your data, you will always see that. Of course, your brain is going to try to overinterpret it, to try to find features that are not really hidden in the data. Then you have the statistics. You can get back to us at the booth, and we can help you to find, is it just by chance, or is it really some feature that is interesting? So I think the best thing is to go to a few, let's say, case studies, examples. I was involved a few years ago in a project where we were looking at some issues on the construction of an aircraft, some measurement issues. And of course, you can measure how often is it good, how often is it not good. As soon as you don't put your bar plots on a horizontal line, but you just put your bars on the shape of the aircraft or of the section, you directly start observing some similarities, some symmetries. And the next thing is that all these guys that thought before, the scientist has no idea about the process, they just knew, some consultant, they won't be able to help. When they see these pictures, they directly recognize, this is the position of this kind of door, so there is a reinforcement there. It's quite clear that we have more issues. So try to find for every issue you have, they had a spatial issue here. See, adapted data representation that will help you understanding the problem and discussing the problem with people that are not experts. Another interesting example was a research project with the University in Los Angeles, and the people did a psychology study where a lot of people had to smell some strong tastes, and they wanted to see and then to click on an iPad on the color the smell reminded them. And they wanted to see if there are differences between these colors between different regions and cultures. So if Asian people react differently to specific smells than European and American people. And basically they had to stop this project because they said, no, there is no correlation, there is absolutely nothing. And I was thinking about it. I mean, one of the smells was burnt rice. I mean, if you have ever smelled burnt rice, you know that you're not going to click the same color as flowers. It's quite obvious. So before doing the analysis, trying to correlate anything, just plot all your data you have. These are the groups, the cultures, and just one dot for the color that has been chosen. And you see, maybe more or less directly, the flower column is quite different from the burnt rice. So even if these guys thought there is no correlation, there is nothing to find out, then you see, as I can see the difference, there will be an algorithm that finds it, that make it, and that shows that it's significant. And the reason behind this the whole analysis, or the reason why they couldn't find out any correlation, is that they considered every color as a category. So brown, dark brown, and black were two different categories, as dark brown and magenta would be two different categories. So they didn't really consider the distance between the colors. Some colors are very close to each other, and some colors are very far away from each other. If you throw away all your data in any kind of data mining algorithm, no chance that your computer will find out, okay, these are RGB codes that should be translated into LAB codes, and then you have a metric on that, you can calculate the distance. So consider your color, your data, plot it properly, and then you know how to tune, how to add extended values, extended columns to your data in order to throw it into the best algorithm you think of. One more example was quite interesting. About 2 months ago, I had a discussion with the quality head of a psychiatric unit of Canton Hospital in Switzerland. And for this ISO certification, they have to measure a lot of KPI data. And one of them, it's just some data, some copy of the data, it's not the original data, was related to satisfaction of the employees, of the customer, of the patients, of anyone working around or in the large units. And I looked at the plots and I looked at that, and it's quite surprising that suppliers were so unhappy about the satisfaction level. And we discussed about that, and he told me, yeah, the issue was that nobody answered, so I had to put a 0 and then I plotted 0. Okay. And then you start wondering, yeah, but these guys are quite happy, but how many do you have? Yeah. And do you have the same numbers as here? So can we really compare these things? And these plots are nice, but you can't do anything with it. You don't know how much data is between these plots. So why not? We have an issue, we have a plot which is more or less reasonable, with more or less known. Go to the next step and use what modern software can do, and go to the shadings. So you have basically the same plots, but you use this shading to say how much confidence you have in the data. So here, not much, here quite a lot, here quite a lot, and here nothing. You don't really know where it goes. So here you don't tell that the suppliers are unhappy, you just say, I don't know anything. The last examples I wanted to show is one quite common issue, typically in churn analysis. We did a project with an insurance company in Switzerland, and we were wondering, okay, how many people leave and get contracts in another company. Okay, usually people are just jumping from one presentation to the other data presentation. First, you look at the cantons and you say, okay, how many people leave? And then when you know how many people have been leaving, you ask yourself, but how many people are there in this category? And the presentation is completely different. So depending on the question you want to answer, maybe you are interested in the number of people or you are interested in the percentage. Why not think in that spatial situation about one data representation where you can see both and that gives you some meaning? We called it the SC plot for Swiss chocolate plot, even if it's a bit far away from chocolate. But one of the ideas, I mean, we have this bar plot, we have a way of extending this bar. Why not make the depth of the bar related to the amount of people you have in this category? So a lot of people from Canton Bern and not too many from Canton Jura. And then you keep the height as the percentage of people churning. You have the whole view, you see everything at the same time. Depending on your question, you can understand it and try to read it the way you need. And one more interesting thing is that you can even make multiplication. If you multiply this dimension by this dimension, you get basically the number of people you have in this group. So I think thinking about the issue you have and thinking about the best way of presenting the data related to this issue is quite important. So we can already come to the conclusion where I say, before starting basically anything, in our opinion, in big data, anything could be hardware-basic, so buying some kind of large data cluster or getting a cloud solution or doing analysis, look at your data and consider its validity and truth, and what you can do is that plot it and try to get a feeling of the data. So the next point is, that's the reason why we are a consulting company and we don't sell any software. We are convinced that this step cannot be replaced by a machine because it's related to human people. These are the ones that had the issue at the beginning, and it's related to human people at the end because these are the ones that will take the action at the end. And once you have done these steps, try to keep in mind to work with partners or with IT solutions that give you this flexibility. So there are quite a lot of software where you have basically no chance of doing this kind of plots. Excel is one of them, but many other ones that are much more expensive than Excel don't offer you so much flexibility. So I wanted to thank you for your attention, and thank you for letting me the opportunity to talk here this afternoon.
Thank you very much. Here is all about communication with graphics, I guess. Are there questions?
How do you actually make these very specific plots that cannot be generated by someone?
Usually we use some kind of rapid prototyping software like R or MATLAB or things like that. Give you this flexibility.
And do you make the presentation manually? So this is something you develop with your experts and you can support it?
Usually we develop it case-based. So on the case we try to develop the adaptive visualization, and then it's interactive with the customers because there are some visualizations that fit to their needs and some that don't really.
More questions? How does it work? I mean, you present some such graphics, you have it implemented in R, and then the customer don't want to have it regular basis and their software, operational software or something like that?
In the first step, usually they need a one shot. Just you have to debug to find out the solution, and if they have some needs on the longer term, then you have a way of offering them the standard code how to basically implement this kind of presentation or elements in their own environment.
Another question? Otherwise, let's thank Rodolphe, Dewarrat,